for being here. I'm super excited. Actually, hearing at Keith's talk, it's like some things in my slides are valid as of today, but with XCM before, they're not going to be. But I mean, it's still interesting, no worries. So yeah, I'm Alberto. I work at developer relations at Moonbeam. Today, the talk is going to be more generic. It's not going to be about Moonbeam. It's going to be about XCM. And so computed origins for cross-chain execution. So it's actually related to a couple of slides that Keith just presented. But before we actually do this, let's take a step back and think about consensus and cross-chain, right? When we have two completely isolated consensus systems, right? We have blockchain 1 with consensus 1 and blockchain 2 with consensus 2. They don't really know each other. They don't really know that the other one exists. And that is the current situation with a lot of ecosystems out there, but not Polkadot. And we'll get to that. And so basically, there are things called GMP Protocols. It stands for General Message Passing Protocol, right? That is basically, it connects isolated consensus systems. And the way that this works is that if blockchain 1, consensus 1, wants to send a cross-chain message, right? They don't really know that there's another ecosystem out there. But the GMP protocol basically acts as an intermediate consensus. And so what this means is that the GMP protocol will actually fetch that message, will interpret it, and it will have its own consensus mechanism, right? That could be a multisig, MPC, a network like Axelar proof of stake. And then it will basically execute that message on the other consensus mechanism, right? And so keep this picture in mind, right? You have one blockchain, another blockchain, three consensus mechanisms acting together to relay a message from one to the other. And so think about the weakest link on the chain, right? If one of them consensus break, you're breaking the whole interoperability path. And so if we go to Polkadot, this picture speaks by itself, right? You have basically parachain A, parachain B, you have Polkadot, and one consensus that governs them all, right? It secures them all. It has many names, shared security, the relay chain security. But what's really interesting is that both parachains are relying on the same consensus mechanism for chain security. And so if parachain A wants to send an XCM message to parachain B, what this is going to happen, what that's going to end up is that you're going to have state changes on parachain A and state changes on parachain B that are checked by the same consensus mechanism. So now it's a lot more robust, and that's why Polkadot's architecture is quite unique in terms of interoperability, because you only have one consensus that you already trust. I mean, you're already thinking that the parachains are relying on Polkadot for consensus, and basically they're just sending a message, hope that the message gets executed, but the state changes that are happening on both chains are checked by the same consensus. So I really like this picture because I think that it basically speaks by itself compared to the other one before. So now a part about XCM. This is going to be very high level, but it's sort of to set the tone when we speak about remote origins a little bit later. And so the way that I like to explain XCM is that XCM are a set of instructions that by themselves, they don't mean anything, but the combination actually results in concrete actions, something actually happening. And when I'm in my computer, this analogy makes sense. Right now it doesn't, but I always say, if you only tell me, Alberto, stand up, nothing happens. But if you tell me, Alberto, stand up, walk 10 steps to the right, and flick the switch, those combinations of instructions end up in a concrete result. So the XCM is fairly similar in that sense. You have two parachains acting together. There are some XCM instructions. Sometimes you have part of the XCM instructions being executed on parachain A, and then others being executed on parachain B. But the combination is what actually results in something. In the case of token transfer, for example, this is the typical sort of flow of XCM instructions. If you want to transfer, let's say, a token from one parachain to the other, part of it is executed on parachain A, and the other set of instructions are executed on parachain B. If you grab only one instruction, that doesn't do anything, but the whole pack actually results in something happening. And the same is for, this is called remote execution, right? If a user on one parachain wants to execute something on another parachain, right? A user on Moonbeam wants to schedule something for automation on Oak, for example. That is something called remote execution. And we'll expand on this third topic a little bit later. So we're jumping a little bit here, but there's one important concept that you need to understand in order to understand remote origins, and that is something called the sovereign account. Parachain sovereign account, relay chain sovereign account is just sovereign account. And so the concept of sovereign account is basically that you have each parachain or the relay chain has an account in the other participants of the ecosystem. So basically, Moonbeam has a sovereign account in A-star, Kala, Parallel, Equilibrium, Centrifuge, whatever parachain exists out there. And the only way that this sovereign account can be controlled, it's via democracy, XCM, depends on the palettes and so on. But it's an account that represents the entire blockchain, not a single user. And it's keyless, meaning that there's a private key, no one knows it. But it's basically the only way to control it is via remote execution or XCM. And this, if you're familiar with Ethereum, you can think of it as like when you execute the XCM message on another chain, it's like the message sender. I mean, that's like an Ethereum analogy, but just to get sort of like more terms on the table. So now we're talking about remote origins, right? And Keith actually mentioned it a little bit, but I'm going to expand a little bit more into it. So yeah. So what is remote origins, right? Basically, the idea that, and this is for me actually something that is really exciting because it's the idea that a user on a parachain, on the relay chain, can control other accounts in other parachains or the relay chain without having to move to that ecosystem itself, right? So imagine we actually have tutorials where you can actually stake Glimmer without having to jump to MetaMask and then do it on Moonbeam itself. You can actually, from the Polkadot relay chain, imagine there's an application where you're actually staking Glimmers without having to, OK, I'm going to send my Glimmers to this account. I'm going to connect MetaMask and so on. So this actually opens up a lot of possibilities. And the high-level way that this works is that one of the instructions that is called the send origin, and Keith was actually also presenting that, basically, actually, when this XCM message is executed on the destination chain, that will actually calculate a new origin or a new message sender to execute the XCM through, OK? And so there's many names. Originally, we called it Multilocation Derivative Account. That was very long. I saw the name of computed origins or remote origins or mutated origins. But the idea is that one user can control multiple accounts that are keyless. No one knows the private key. And the only way to access that account in this case is via XCM execution. Well, the main way, let's say. And so the idea is that you actually just hash. You do hashing to calculate this new origin. And so the XCM message must include, generally, a send origin instruction, and then the receiving chain can use this to calculate the new account that it's going to execute the XCM from. And just thinking about all the possibilities that this opens up, it's great, right? I was speaking earlier with someone. I was like, imagine you're using a DeFi protocol on Moonbeam, and then you have this little pop-up. It's like, hey, do you want to automate these actions powered by Oak? And the user never has to leave the app Moonbeam, right? Everything is happening underneath. It's pretty complex from a developer perspective, but that's the point, right? And users should not suffer for bad UX if the tools are available for developers to build these sort of better user experiences. And what's really cool is that before, there was no real standard in Polkadot, right? So I mean, Moonbeam had its own way to calculate these new accounts, and there was no one really working on a standard. And there were a couple of PRs that actually set sort of like a standard in Polkadot. And that's really cool because it means that wherever you are in the ecosystem, you can calculate the same account the same way. And if everyone uses the same standard, so this is really, really nice if parachains do it, right? Alberto and Moonbeam will control kind of the same address in all the different parachains in the ecosystem. And it will have a different account, for example, on the relay chain. But it's kind of like the same underlying account for all the parachains, which is kind of nice. And so let's briefly discuss how this account is calculated, more or less, right? I mean, we're not going to go into the nitty-gritty of the math, but just to show you an example. So imagine you have a relay chain, parachain 100, parachain 200, and then some child chains. This is theoretical, all right? But let's say they're there. Actually, I grabbed this from one of the PRs, the original PRs from a person from Centrifuge. And so I used the same example in just a nicer diagram. And so in order to calculate the remote origin, right, first, the latest proposed PR, I think it was by Gav, is to use this prefix, right? So we're going to hash something. We're going to calculate the hash, but the hash of what? And so depending on how the message is passed, if it's from the relay chain to a parachain, we're going to just put this text inside the hash. If it's from a parachain to a parachain, we're going to put this text inside the hash. And it's from a child parent to a parent, we're going to use this text inside the hash. Okay, so basically, if the message is from here to here, it's one. If it's from here to here, it's the other. Or if it's from here to here, it's the other one. And so then you basically, this is not 100% accurate, but for this presentation it is. We're going to use the Blake2 hash of basically the prefix that we just calculated depending on how the message is moved. The parachain ID, if it exists, because if you're moving a message from the relay chain to the parachain, that is not really valid. The account type, so I mean, Moonbeam is quite unique. I think Mangata is another parachain that it's using. We use Ethereum-style accounts, so we use 20 bytes accounts. And then the other ecosystem parachains use account ID 32, which is another type of accounts. And then the address itself, okay? So these are like the main components of how you calculate this new remote origin. And remember that this remote origin, no one really knows the private key, right? I mean, it's a keyless account that you can control only, in this case, via XCM, or mainly via XCM. And so I put this on the top right corner. Luckily, I saw it. But it's a repo that we have with a lot of like XCM-related tools. And we actually just updated a tool, a script, to calculate these new origins in case you're interested. For example, I think for wallets, it's very helpful, and so on. But in case you're interested, there's a tool that allows you to calculate this remote origins account. And you can use it as an example. Then you can create your own like set of functions. But so imagine we have a relay chain, a message from the relay chain to the parachain 100. And so basically, because this is moving that way, this is a prefix that we have to use. And then we put that in the hash. And then the hash would be more or less parent chain, no parachain ID, and then account ID 32, because that's the type of account that Polkadot relay chain uses, and then 0x, whatever. This is the decoded address, so it's not the same one that you see, for example, in Polkadot.js apps, but you can easily decode that to put in the hash. And then if you use XCM tools, so you can see that we're actually representing that sort of like path with this like basically saying, this is the account, this is an example for sure, this is the account, this is parents because the message is coming from the relay chain, and then you run the script, and the script is going to tell you, hey, we're going to calculate your remote origin using this prefix, parents1, this is the account, and then this is the calculated address for that 000 address. And this is if your message is going to Moonbeam or Mangata or whatever other parachain that uses the other type of accounts, it's going to be this one, which is the same, just cutting out the bytes, the extra bytes that we don't use, okay? So now if we move the other way, so if we are in parachain, sorry, not the other way. If we're in parachain 100 and we want to send the message to the parachain 200, and we want parachain 200 to execute that message with this remote origin, it is fairly similar. We just changed the prefix to be sibling chain. And then we have the Blake2 hash of sibling chain, parachain ID, which is 100, account ID 32, because in this case, I just use that as the account type. If it's from Moonbeam, it has to be account key 20, and then the address itself. Notice that in this blob here, there's no information about parachain 200, right? So this means if any other parachain, 300, 400, whatever it is, uses this standard, they're going to come up with the same value. And then when they encode it, it's going to be a different, like, prettier number, but the underlying account address is the same. The decoded version is the same. So if you use XCM tools to calculate this, you can see here that I just appended -p for the parachain ID. Actually, I should have put 100 here. This is my bad. This is 100. Oh, and actually, I put 1 here, so I'm right. But I should have put 100. And then parents1, because the message is moving towards one level and then going down. However you want to like explain parents, we have the account ID here. And then the program is going to throw the two values once again, the one for parachains using 32 bytes, and then the other one for 20 bytes. Okay, so depends on your parachain. So why I think this is important is that it's going to create better UX for seamless cross-chain, right? I think from a parachain perspective, we've got to stop thinking about parachains and more for the ecosystem as a whole. I think, for example, applications on Moonbeam should be able to access other services in the ecosystem without having to say, no, you want to have prediction markets. No, you got to go to like Psychice and move over there, grab your wallet, connect to Psychice, create your whatever. And that doesn't provide a good UX, right? We got to basically use these tools that Polkadot is giving us to create better UX. And I think this is the first step to provide it seamless cross-chain integrations to the community, to the end user, which is what's important. So because I have time, I'm going to go through how the flow would be more or less, right? So if you want to do remote execution from parachain A to parachain B, what's going to happen is that the XCM message is going to be executed using parachain's A sovereign account. But because we put the sent origin, right, that in the future is going to be renamed maybe, we're going to have to mutate that origin with the math that I just did, hopefully, if the parachain applies that. With the math, we're going to calculate a new origin to execute that action. The next XCM instruction is called withdraw asset. What this is going to do is that we're going to use that other account that we calculated because we don't want the sovereign account. And we're going to take tokens out of that account. It depends on how the flow is. If you, for example, want to pay for execution on Moonbeam with Glimmer, it could be Glimmer. And then those accounts are going to be put in something called the holding register. The way that I explain holding register is like a shopping cart. You're going to put them in a shopping cart that you don't own it anymore, but it's there to be used later on in the XCM execution, okay? So you take funds out of this computed origin, remote origin, and you're going to put them in this shopping cart to be used later. The next instruction, once again, a combination of XCM instructions. The next instruction is going to use that money in the bucket, in the shopping cart, to buy execution time. So we need to buy execution time on parachain B because we're executing something. We're taking block space or block usage, right? And so this instruction helps us do this. And then last but not least, probably the most important, well, I wouldn't say the most important, but one of the crucial instructions is transact. So transact allows you to say, I want to call these bytes on this remote parachain. These bytes might not mean anything on Moonbeam, but for example, an oak could be, I want to set up this automation thing with this, and that, right? It just depends on what you're trying to do. We have actually a couple of tutorials in our documentation side. I think I mentioned one already where you can like stake Glimmer from the relay chain, right? It's just an example because you cannot do that right now in production. And the other one that is actually pretty cool, and that's why I'm really excited about this, is remote EVM calls through XCM. So you're going to be able to call Moonbeam's EVM using XCM, right? And what this means with the remote origins is that a user, for example, in a parachain that don't have XCM, like Hydra, Centrifuge, they can use Moonbeam's XCM without having to let me move from Centrifuge, connect my wallet to Moonbeam, et cetera. Like for me, that has to stop, kind of, right? We need to start thinking about these cross-chain experiences. And so this, in combination with remote EVM calls, is going to provide a better UX for the end user. And the idea is that we're going to have this like rich ecosystem where each parachain provides a service, right? But we don't really necessarily have to be jumping around chains to actually use those services, right? So hopefully, this sort of like helps you understand, at least the way that I like to see XCM is that it's a tool that needs to be used by developers to create really complex infrastructure, right? For that so that users don't have to like carry the burden of like hopping and moving around, and they have a really seamless UX. And all this is thanks to like Polkadot's architecture and XCM that it's powering all these possibilities. So yeah, that's all I have for you today. You have the QR code if you want the presentation and slides. By the way, these all like images, most of them were using the Polkadot Icons website. So they're really great to get like images and things for the presentation. So kudos to that. You can follow Moonbeam on Twitter, Telegram, Discord, the website, and you also have my Twitter handle and Telegram if you have any questions. If you're interested about working with remote origins, you can reach out to me. And yeah, thanks a lot for your attention. So.